have a multi-component tank system. So unlike last time we just had to deal with one tank or even three tanks in a series, but we only had to deal with the flow. Now we have to deal with temperature and concentration. I should probably also mark concentration. All three of these streams are going to be different, and then we have the same, actually, I do believe this is an overflow tank. So, yeah, there we go. And all three of these streams, the inlet's going to equal the outlet. It's well mixed, da 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 da. We already know that. So first, we're going to have to find the volume, which is Q in minus Q out, as always. But since we have three streams, this Q in term is going to be a sum. So it'll just be this sum of Qi minus Q out. Because, yeah, we get that. And we also have to deal with these two as well, the difference in temperature, or the change in temperature and the change in concentration throughout the entire thing. This one's going to be much the same. It's going to be from 1 to 3, and it's going to be Q, but also times C minus Q out concentration of the tank. Since it's well mixed, this concentration Ca equals Ca out. So we can say that for sure. This temperature term is actually wrong. I think we also need the heat capacity and density. So this one is equal to also 1 to 3 Qi Cp rho minus Q out Cp rho. So you go ahead and cancel these here. So we're just left with the dTV. And these equations, both we can take, we can change volume to height by taking out the cross-sectional area, because that's how you find cross-sectional area. I realize I'm not on the screen, but I'm still here. So dH equal to dt is equal to 1 over AC, because we took out that AC term and moved it over to this side, the cross-sectional area. And then similarly with concentration. Q out Ca, and then same thing. And so far we've got these all taking out the volume term because we use volumetric flow. So in order to avoid having to deal with a product rule, because we have two dependent variables, we want to separate those out for these bottom two equations. So we have the change in concentration times the change in height over time plus the height times the change in concentration is equal to blah blah. I'll write that in a minute. And then we have temperature times the change in height plus height times the change in temperature. And of course we get from 1 to 3, Q's 1 to 3. And then we get Qi minus Q out. Realizing I might have done this wrong, I think I need actually a Ti here. Should carry the Ti. Definitely need that. it's not temperature without temperature. So Q out T, let's just have it's T because T equals T out. So then need a heat capacity term for here. So it doesn't quite cancel out. Now we can simplify these equations for our, let's sit here, final thing. So to just get 1 on one side, we need, I forgot the 1 over AC term. 1 over the cross-sectional area. So dt is going to look something like, dCA is going to look something like, we just want to isolate it, so algebraically it's going to be all over H, and it's going to be, that's too small. Minus, because we have dHdt already, it's going to, once we put this into coding, we'll be able to find this already before, so no need to worry about there being a differential equation within a differential equation. We'll work it out. And then dt is going to be very much similar, except qi minus q out, heat capacity times temperature out, times 1 over the cross-sectional area, minus T dH dt all over H. All right, and now we're ready to put this into code. Okay, I already erased the problem because I finished it, and I realized going back, I made a mistake. I said it was an overflow tank. It is not an overflow tank. So we still have the dHdt term. The height does change. Just wanted to clear that up for post.
Back with the continuously stirred tank that is got 3 different streams. And so here I'm going to set out these values. So we got 85, 60, 80, 65, and 90. So T0 is equal to the array of 80, 65, and 90. And then we've got CA0 is equal to 0.01 and a half, 0, 1 and a half. And then we've got initial Q's, so Q0. Alright, and then we got some other little things to here, like the size of the hole is equal to probably 0.1 meters. Yep. 1, and then the AC, the cross-sectional area, is equal to 1 meter squared. Yep. Alright. And then we will need to define gravity is equal to 9.81 because in the last ones I've forgotten to do that and it's messed me up. And we need a time, which is going to be 100 seconds. All right. And I've got all these up here. These are just our typical housekeeping things. You already know what numpy, numpy, plotly, and solving PR. This root is going to help us later. And now it's time to define the function. Let's just call this the tank. And we need it with respect to time, a vector quantity of height, concentration, and temperature. Then we need the initial conditions that we're giving it, which are CA0, T0, and Q0. Q0 is going to be different from Q out. All right, and then CA, no, probably we should do it. H, CA, and T is equal to V. We should start by defining our Q out, which is AH times the square root of 2GH, because, yeah, well, you need that to be there. Alright, there's our Q out. And so next we need dH dt, which will be equal to this sum of all these vectors of Q0. So numpy sum of Q0 minus Q out, all divided by the cross-sectional area. Of course, it's not capitalized. Yep, likes it so far. So then dCA dt is going to be equal to the sum of Q0 times CA0 minus Q out CA, all divided by the cross-sectional area. No, I need a I need some more parentheses here because I also need to multiply this by the differential equation, the dCA dt, or dH dt, yeah, because it was changing height. And then this dt dt is going to be equal to another sum, but this one's going to need to be multiplied by alright, looks like I'm doing this slightly wrong. This is supposed to be over cross-sectional area first, then times CA is the concentration times the change in height, and then all divided by H. I algebraed that out in the last one. I believe that's right now. Yep, that looks better. Alright, so then dt is going to be equal to the sum of, I think it's Q0 times T0 minus, nope, the minus is out of here, Q out times T. Divided by the cross-sectional area. and then times t dh dt, and then divided by the height. And then we want these returned into an array of just all three of these, dh, dt, dca, dt, and dt, dt. Alright, it acts like it's working, so I think it likes it. So the next thing we're going to need to do is solve this with root. And this root's going to, all of these three, it's going to find these once these converge to 0. And with that, we're going to want to do an anonymous lambda function, because you don't want to just create a whole new function for this. And since this is going to be time independent, since it's a steady state, we only need to know about v. And that means that our initial guess, x naught, oh, I need to give it the function, that's right, and so the tank. Alright, now we can move on. So then we have 0, because time doesn't matter. We have that same vector of our height, time, and concentration. And then we need to have CA 0, T, or let's do this in order. Q0, CA 0, and T0. And I'm beginning to realize that I might need to redefine these as something else, because if this function thinks that it's only getting those zeros, then it might not work well. Alright, and these have to probably be the same in. So if I just have the function running at only the initial steady states, then we'll be wrong. And now I need to give it the initial guesses, and something I didn't derive, but we can just algebraically determine. We already know the initial height, so for that one it's as easy as summation of these things, nope, not a comma. No, that'll be summation of q in 0, and then we want it to be divided by the size of the whole, and we want it to be squared, and then we want it to be divided by 2g. And I think that'll work. Oh, and then I need to give it, I need brackets for the array, and a period to actually make it an array. Alright, let's see if the algebra wants to work. Okay, and then let's just say concentration will be about half, because that'll be in between the concentrations, and then 70 approximately for the temperature as an average. So we need U and then U. I probably messed up parentheses here. Alright, hang on. Let's just totally rewrite this whole thing. This needs to be an array, so alright. Array. Okay, there we go. That needs another set of parentheses. So we give it here and here. And then I can put up, there we go. Okay, and then I can put that guess. And I guess close off that parentheses. And hopefully you work. No, you don't work. What did I do wrong? V is defined. You are horrible. I probably, let's see. Let's try setting you to the solution, because this will be the solution. No? You still want to say screw you? Alright. Alright, well I have found some errors. Alright, let's see. It's supposed to be capitalized. That'll at least get that out of the way. Maybe this comma's extra. Oh. Oh wow, it was that simple. Alright. No, you're still not doing it right. These should be different values. And it's probably gotta be in this block. Hey, I found it. It's not supposed to be multiplication, it's supposed to be subtraction. Because that's how the algebra works. Alright, that's looking better. I don't think this is right. Yeah, this is definitely not right, because this is supposed to be much higher than 4 degrees, 0.4 degrees. But this looks fine. These two look, oh, what? Now this height's not fine. Okay. Alright, maybe it's in these parentheses. I'm gonna just start. Oh, you're good. Nope, still wrong. Not sure why, but still wrong. DHDT, DCA, DT. That's good. Q out's good. Good. The only other thing I can possibly think I got wrong is maybe switching the order of these variables. Maybe that does matter. I think I put Q0 should go here. Let's see. Then now it works. Okay, bye. Alright, well that's part B. That's part A of the homework. Part B, now I'm going to do this in the same one since it's the same problem. Let's get some space. We need to have a second T, or a second everything. CA is 0 is going to be different, or is going to be the same. No, then we'll call this CAN1 equals, I think I just got to go CA in 0 dot copy, and then T int 1 is going to be T0 dot copy, and then it's Q that's going to be different. So Q0 Q into is going to be equal to 55.28 and 0.6. Zero 0.28, 0.36, 0.6. All right. So now that we are ready, now that we have that initial steady state done, we need to start graphing this stuff out as it changes. So we need to have the result is going to be equal to solve IVP, because we don't just want an initial, we do want the initial value. Now, okay, fine. And we want it to be lambda of t and v, because we actually want time here. And we want the function of tank with t, v, and instead of q0s, we want the q1s. We want the q1s. And tn1. And then we need it from time or 0 to the time that we set, and then we need an initial y value. So we want the initial y value to be the solution from the last thing, from the initial steady state. So it's not just starting from scratch. And then We want the method to be Redot. That's not really necessary, but I'm doing it just because. And we want the dense output. Where did that come from? I'm not entirely sure where that came from. There we go. Now it's a lambda function. And it still doesn't like it. Oh, hit the wrong thing. First off, get rid of you because I have no idea what you are. No, it still doesn't help. Maybe it needs parentheses just like figures does because random functions need these sometimes. Let's clear everything up. Oh, okay, that clears everything up. Alright, now we just gotta make a time plot. Numpy space from 0 to time with 1,000 in between. And we want a vector of the height. Is going to be equal to solution from the last thing. The solution of the last thing with respect to the time. And then we just get to make subplots. We want one row, 3 columns. We want to get some general housekeeping. X is equal to time, Y is equal to height. Same thing here, but concentration. And same thing here, but temperature. And then we want to put U in row 1, column 1, and have U be column 2. U be column 3, name U height, name U concentration, time, or temperature, and I messed it up. Maybe these are wrong, these 3 things. Oh duh, why would I needed the plots, I don't need the variables. Otherwise I made them for nothing. Oh, you're not called CA plot, you're just C plot. Alright. Now we try. Yay! It's exactly what I wanted. And it looks right. And that's from the initial steady state to the new steady state. We can track each of the changes. Temperature goes down with respect to concentrate, or temperature goes up when concentration goes down, and then obviously height goes up because you speed up. No, actually you don't speed up the. You do speed up one, you slow down the other. So I guess Q1 matters a little bit more in the grand scheme of things. Yep, the only 2 you change are these 2. Everything else stays the same. Alright, well that's the end of part 1, or parts A and B in the same video.